All right, welcome everybody. So a lot of the talks and the kind of things yesterday reminded me of kind of a book and one article. So if you look at guys like Lars Bak, who has been doing, VMs for many years, or Phil Wattler that you will see soon, that has been doing functional programming for many years, or Gilad that's been doing, Smalltalk and so on for many years, you see that it takes a long, long time to become an expert in something. And these days, because of the internet, there's a lot of people that think they are experts. And the sad thing is that, if you're trying to move from here to here, you have to have the opportunity, to do that. So you have to have some kind of stable work where you can kind of become an expert. So, and I really hope that the economic situation doesn't stay this long, bad this long, such that many more people can move from the amateur phase to the expert phase. And this article is very interesting. It says that it takes about 10 years to become an expert in some field. So, if you want to become a programming language expert, you have to do programming languages for 10 years, and then you can start designing your own language. So,
everyone starts designing their own language like 3 months in.
Exactly. Exactly. So, talking about 10 years, so these are vintage slides from 1997, where I kind of, turned from a kind of theoretical computer scientist into a whatever, I don't know what I'm now. And so the problem I was trying to tackle was the problem of web programming. This was the height of the internet bubble, so I thought, let's tackle that. So what I was trying to do is to say, let's, how does this work? Well, there's usually 3 tiers. There's some data, some business logic, some client. Each of those have different data models, SQL, objects, XML here. But the way you kind of glue these things together is you get something really weird. This slide is 10 years old, but unfortunately, the situation is still the same. It hasn't changed. Since I was a young Erik, I thought, Haskell is the answer to everything. So we built a whole stack that uses Haskell everything. So we had the Haskell DB, Haskell server pages, Haskell script in the browser. But of course, who cares about Haskell? Who here has written one line of Haskell, excluding Phil? A couple of people. Not bad. Anyway, does it work? Okay. So instead, I stole the ideas from Haskell and put them into C# and VB, and they're called Link. So we are using Link to kind of grease this kind of distributed programming. So what we did before is with Link to XML, Link to objects, and Link to entities, and Link to SQL, we used Link to kind of bridge the impedance mismatch between the different data models. What I'm going to show you today is how you can use Link to do the distributed computations, because there's 2 problems there, right? There's the 3 different data models, but now if you're running across tiers, you have to deal with distributed computation. So Link is the silver bullet for everything. Okay, so we have had silver bullets, and also today I'm going to make you rich. I'm going to send some money. Because what I want to do is I want to show you how we can kind of, look at a collection of money, collection of coins here, real money, and view them in 2 different dual ways. And the dual ways, and Thomas talked about, reactive programming. But what is really reactive programming? Well, reactive programming is the jewel of interactive programming. Now, what is interactive programming? Well, that's the jewel of reactive programming. That's it now. Interactive programming is where the program begs the environment for input. So it's like your old style, C style, old school, console.readline. So your program says console.readline, and then the environment says, here's a string. Okay? And then you say console.readline, but you're blocked until the environment says, here's your value. On the other hand, a reactive program, you wait for the environment, and the environment just throws values at you, and you always have to be able to catch them. So let's see how that works with money, because that's always concrete. My math teacher always said, if you explain something with money, everybody understands it. So, who wants to be the innumerable interface to my coins? Any volunteers? Oh, look at this. Oh, Burton, wrong answer. So, you're the enumerable collection. So how does that work? What is the interface? Well, first of all, Burton asked me for get an enumerator. So, get enumerator. So I gave him an enumerator. And so now he can ask me for the next coin, right?
May I have the next coin, please?
Well, so he asked me for the next coin, but while he's asking, he's blocked, right? Because, it's me who decides who to give the next coin. Look, you're here. And so now he has one. And if he wants, can he now have the next coin, please? Brett, are you looking for a seat? Okay. Here. Okay, so here you see this is an interactive computation. Burton has to ask me all the time for money. And that's kind of, people don't like that. So now, who wants to be the observable collection? Okay. Look at that. You see, every time he has to react to these coins. So what I do is he registered to me that he wanted to be the observable collection. And then I just was like, and then now I say complete. So now, after this, no more coins to your way. Okay? So this is the difference between observable collections and reactive collections. And now...
Coins hurt more than mouse clicks when they...
That is true. That is true. But he's a tough cookie, so... Okay. So now, I've kind of... Yes, Phil?
Very entertaining, but I am not a .NET expert, so I don't know the observable interface. So could you give an explanation for people who've really never seen it?
That's what I'm going to do now, because you're a professor of theoretical computer science, right? So now I'll show you, because if you're in doubt, you always...
Already, it doesn't help.
No, but wait. Wait. You will get there. Okay, so duality, right? Duality allows you to kind of connect two different things that are kind of symmetrical, right? Here, like negation distributes over or becomes and. Well, for free, I get that negation distributes over and becomes or, right? So we know some more if you do some soldering, that capacitors and resistors are dual. So you only have to understand one set of formulas and you get the other ones. So now we're going to consult Phil and say, Phil, what is this duality? And Phil says, well, if you want to dualize something and you have a function from A to B, you just swap the arguments and the results. Okay? And here's the great thing. That the duality principle says that if some theorem holds here, some related theorem, a dual theorem, holds here. And this is how we're going to derive observable collections from enumerable collections by blindly applying this principle. And I love math. To do math, you don't need any brains because it's all symbol pushing, right? I mean, long division, it's just symbol pushing. So I'm just following the algorithm that Phil tells me to do, and I'll just blindly do it. So let's go. So here's the enumerable interface. You're a Java guy, you wrote a book on Java, you know the iterable interface? It's the same, a little bit renaming, That's what the .NET guys do. They take the Java stuff and rename it. But we're also adding value. Look. Anders showed that yesterday, right? So these things are covariant. So there's the covariance. So the enumerable interface. So now I'm going to do exactly what the mathematicians told me. But for one thing is that this thing, enumerable, also implements idisposable. So really this is a conjunction of two interfaces. So I'm leaving for now idisposable as is. Because I only want to dualize the enumerator and the enumerable thing. So I want to leave the disposable as is. So here we go. What did the mathematicians tell me? Swap the arguments and the results. Okay, going to do that. Ta-da! Okay, so enumerable, well, it returned an enumerator. That now becomes the argument here. It took nothing, and, well, because the enumerator was a disposable, that stays, and that adds nothing. Okay? And then the out becomes an in. So it's covariant becomes contravariant. Okay, so I've done nothing but just swapping the input and the argument. Yep? Okay, now let's look at the enumerator. Well, covariant becomes contravariant. Bool result becomes a bool argument. A getter here becomes a setter. And then again, if you look at the Java thing, it says that, I think in Java, move next throws, and in .NET, current throws, or vice versa. But either of these things can throw when you call them. So that's like an implicit result that I have to make explicit here. Okay? So now I have 3 methods that I've just derived from swapping the inputs and the outputs of this thing. Agree, Phil? I'm just doing mechanical dualization here. I'm not interpreting anything, right? I don't even know what this program means. I'm just doing symbol pushing. So now let's switch modes and now let's interpret this. Well, if you look at the protocol for enumerable, it's like you call move next, it returns true. You call move next again until it returns false. Okay? Now instead of passing this boolean in here, you can say, well, instead of passing this thing every time, I only call this thing when this guy is true. So in some sense, this thing is superfluous, right? I just call the method when I want to tell you that it's true. And you usually can do that when you have a boolean flag. You encode that boolean by calling or not calling. So we can get rid of this guy. That's simpler. Having a setter, set only thing is a little bit weird. So let's turn this guy into a method call and then leave this one alone. Okay, so we're just doing a little bit of massaging. So now we get this interface. Yep?
Don't you also need to capture is not completed as well?
Well, that's when it's not complete, this is when this is not called. So until this thing is called, it's not completed. So that's the way I encode it, right? This thing is called, there's no more coins. And no more coins for you, sorry. But, if somebody attaches an observer to me, I can throw some more coins. Anyway, so this is what we get. And now, if you look, and now everybody said, Erik, of course. In the design patterns book, these things are already there, right? Because this thing is subject-observer. That's this interface. And the enumerable, that's the iterator interface. But if you look in the design patterns book, they're not even mentioned as related patterns. Whereas I've shown you that these things are intimately related. They are each other's mathematical jewels. Okay? So they are very, very much related. And if you look in the Java class library, they do have both. So they have iterable and iterator. And then they have observer and observable. But there's kind of a lot of noise. And that's not an interface. This is an interface. They don't have generic versions of this. So they they are there, but not in the nice and pure form. Okay? So, where are we? Well, so the enumerator interfaces are the things for interactive programs, where you ask the environment, move next, move next, move next. And these guys are the kind of interfaces for asynchronous and event-based programming, where the environment throws an event at you. Like if you have a mouse, the way I look at the mouse, the cable, the USB cable, well, I see a whole stream of events flowing through that cable. Or if in asynchronous computation, well, you wait until at some point it sends the value at you. So this is the way we're doing asynchronous computation. Now, where does all this blah-de-blah-de-blah of duality comes in? Well, because these things are both monads and comonads, we can dualize this, and now we know that these guys are monads too, which means that all the link operators are in here. So now we can write programs over these reactive collections using link syntax, because link is just monads. So that's where we get. So now we have turned writing reactive and asynchronous event-based programs into writing queries. And now I'm home, because if you can write something as a query, I can understand it. So let's skip this for a second, and let's look at some real code, and I'll go back to this. So I have a couple of examples. Based on, depending on time, I will kind of, go through all of them, but I want to show this one first. Okay, so why is this relevant for what I'm trying to do? Well, I'm trying to do Ajax programming, and what I say is that Ajax programming is really all about combining events with asynchronous programs. So here's typical Ajax thing. You have your web page, the user is interacting with the web page, so you have to react to events, UI events, and then for some of these events, you're making an asynchronous call to the server, and then you get back the results, and then you have to recombine them here. So you're doing a combination of event-based things here and asynchronous computations across the network. And so this Ajax is exactly the right kind of sample for doing these kind of event-based or reactive computations. So let's look at the hello world of Ajax. Dictionary suggest. So what does this program do? Well, super simple, otherwise I cannot understand it. Little text box, every time I type a character, I get an event. When that event happens, I grab the input. I'm making a call to the server, to the dictionary, that gives me all the words that match that word, and then I update the UI. Okay, and then I type again, I grab the input, make an asynchronous call, update, etc. Okay, so how does this work? Well, first of all, we have to turn .NET events into these observable collections, right? So how do we do that? Well, or this is to do asynchronous computation. So in .NET, you can do asynchronous computations in Silverlight. They're all done with events. So the way it works is you have some class, there's an event, and some virtual method usually, that is the work. And then what you do is you add an event down to here, you say start that thing that will, start that computation, and then when it terminates, we'll call you back with that event. Well, here's the way we do it. There's some kind of, what we do is we just hook up that event handler to our observable collection, such that if we're listening to this collection, we get notified when this event terminates. So this is just some boilerplate code to bridge the two worlds. We have a whole library where we allow you to kind of, if you're using the begin invoke, end invoke pattern, you can expose that as an observable collection. If you have normal events, not just for asynchronous computations, you can expose them as observable collections. So we have bridges from all the kind of standard .NET ways of doing events and asynchronous things into these observable things. We also have a way to get F# async workflows into these guys, F# first class events into these things. So this is kind of a general interface that captures the essence of all these asynchronous things. All right, this is all. This is dictionary suggest in C# using link over observable collections. So a little bit boilerplate code here to kind of get the dictionary. Whenever I look up this string in the dictionary, I get back an iObservable, an asynchronous computation that returns an array of strings, and then I have something that formats that string into HTML. So these are just helpers. Now this guy here says, whenever the key up event happens, get me the value of the input. Okay, so this is an observable collection of strings, where every time I hit the key, I'll get the value of the input stream. And then this is my program. Say for each string in the input stream, look it up in the dictionary, which is an asynchronous computation that will return, and then format that. So this guy is an observable collection of HTML elements. Whenever I hit a key, it will go off to the server, return me a result that I format. Okay? And then I just attach a listener that will update the output. How easy can it be? Right? Everybody believes that this is true, that this works? Does anybody see that there's a bug in here? Who sees the bug? That gets the remaining money. Wes, you're disqualified. Okay, well there's a bug in here. and a very subtle bug. Okay, and this is a bug that I'm pretty sure is in the majority of Ajax programs today. So here's what happens. So I'm typing in R, right? That's an event. What happens is I'm making this call to the server to look up the results for R. Comes back, I update my UI. Okay, so now I'm typing A. So what I get is as the input RA, I'm making a call to the dictionary server. But for this thing, it's, it has a hard time finding, the results for RA. And I'm a really fast typer, so I type array. Again, I get the event, I make the call to the server. And now, oops, this one comes back before this one. Okay? And now, well, oops, now I've updated the UI here with the result from a previous computation. So it's like you're typing and suddenly you get your UI from a previous state. Okay? So this is a kind of, really bad bug. So there's many ways you can deal with this. So one way is to put timestamps and say they come in the right order. Or in this case, what we're doing is we're saying, well, here there's some kind of monotonicity. So I'm not interested when I've typed RAY into previous results. So what we're saying is that whenever this event happens, we're stop listening to previous events. Okay? And so this is a trick from French language lustre, where they have all these kind of combinators to deal with kind of, preempting events like that. So we have a combinator until, and now we have to change our program slightly. We say for each S in the input stream, look up the thing in the dictionary until there's another event in the input stream. Okay? So that will throw away, so it will stop listening to this guy, cancel that thing, and just start listening to the next one. Now you see that I've added another thing. There's this let thing here. Why did I do that? Well, because now you see that these input values here are now duplicated. Okay? And so there might be, since this is C#, there might be side effects in these input streams. And since I've duplicated this input stream, I've now potentially duplicated the side effects. It's like you're saying, something console.writeLine, console.writeLine, So now I've duplicated this expression, and now the side effects are duplicated. So the way you do that normally is I say var x equals, whatever, that guy. And then here I use x. And here I use x, and now I've only done that side effect once. So that's the kind of other subtlety here. But for the rest, it's still very simple. Okay, and if we had a pure language, this was unnecessary, but we have to be very careful with side effects. All right, everything clear? So this is doing dictionary suggest using a link over asynchronous collections. Given the time. Sorry?
If observable is a push model, why did you have to do that? Because the input value should have only been calculated. I would think would only be calculated.
So let's do it with coins. So here's the side effect. So I'm going to push these coins to you, but I'm going to here through this fellow here. Yeah. And he has a side effect because he's still kind of a little bit pissed that he didn't get enough coins. Right. So what he's going, as a side effect, he's going to kind of, take away a few of these coins. Right. And now they end up at your place, and there's a side effect. And now if I duplicate that, you will get nothing, because then he will take everything instead of half. So even in a push model, there can be all kind of side effects going on. So you have to be very careful. And it's really bad. Whenever you mix lazy evaluation or things like this, either enumerables or observables with side effects, your mind explodes. All right. So, future work. To kind of tie it up to what Thomas was telling, so what we also want to do is we want to kind of, do better matching over these streams, where you will have multiple streams, and you want to kind of wait until, say, these two have fired, and then I want to do something, or if these two have fired, I want to do something, or if these two have fired. So this is where we use Claudio Russo's joins library to do kind of joint patterns over event streams. And now you can write really, really powerful programs that kind of, it's like zip, where you're taking two streams and merging them into one, but I can now take n streams and write a pattern to merge them into one stream. The other thing that we're doing, because these observable streams are just the jewels of innumerable streams, in the functional programming community, people have been doing parser combinators over innumerable streams. You can do parser combinators over observable streams too. So you can write grammars that parse your event stream, so you can recognize patterns in one stream using parser combinators or regular expressions or whatever. So that's stuff that we're going to add, and that kind of ties nicely to what Thomas was showing. All right, some related work. I already said there's lots of related work with F# and what Thomas was doing. There's a lot of stuff in the functional program community on reactive functional programming. There's a big difference here. The functional programmers always are obsessed with continuous time. So they're always talking about functions from time. I don't care about that continuous stuff. I want to have events, just discrete things. That's what I can understand. So it's different from that. We're only looking at events, not at behaviors. A lot of people are using...
By different, you mean it's just half of it?
It's just half of it. The other stuff, I think, should be enumerables, because there you're kind of sampling a continuous input. So I think we really should split them in two. So continuous behaviors are enumerables. The discrete ones are observables. So I think there's a good... And I think some people like Connell Elliott is also thinking in that direction now, if I'm correct. A lot of people are using tricks to use iterators for doing asynchronous programming. I'll say a little bit about that. If you look at things like PowerShell and Windows workflow, underneath they also often have a push model where these things react to things and then use that as the composition. So I believe that they all can expose observables. And then, as I said, this is maybe the kind of most relevant work. All these kind of reactive languages. Like I think the Airbus is right, the Airbus control system is written in either one of those. So this is not just some academic pipe dream. People are writing real industrial applications using this kind of programming. I want to say a little bit about this. So just like for enumerables, I can write link or I can write iterators. Here I can write for observables, I can write link or I can write something like iterators. This is what these people are doing. But why is that? Because underneath what this is all about, and Thomas said this is all about continuations, and in particular delimited continuations. So we're not doing nothing more than composing continuations. And so that's why this all kind of works. Anyway, if you want to see the long talk, I will do that. Just was accepted at OSCon, so if you're interested, you can look there or send us email. And Wes back there is also happy to show some demos. We have a lot of interesting stuff to see. There's we have like drag and drop, which is like a nice exercise. We do model view controller. So many examples can be cast in terms of these observables. And I believe that this is really a fundamental interface. Just like enumerable, Anders said, that's the workhorse in .NET. I think observable is, it's equally a workhorse, but then for these asynchronous computations. So, any questions? There's still money here. All right.
Okay. One variation of that question I asked earlier about is not complete.
Yep.
There seems to be one other implicit state, will not, that you're getting out of having, a move next, and now I go false. It will never complete it.
Yes. So in the same thing here is once you have gotten uncompleted, you will never be notified of anything again.
But in the observable pattern that you generated, there's no ability to say you will never complete.
Yes. For example, for an asynchronous computation, what we'll do is we'll say we give you a value and then we say it's done.
Okay, I just didn't see that in the pattern you generated.
That's it is there. I need to kind of, the truth cannot be hidden. Let me see here. That's kind of in this guy here. Where are we? Here. It's this thing called async subject. That's something when it gets a value and when you observe it, it will tell you, here's the value and I'm done. So that's in the implementation of this guy. So, all right. Thank you very much.